Hello everyone. In this video we're going to go over some solutions for 3.3, 3.4 content on the chain rule. So first I'm going to start with some of the 3.3 day 1 questions. So just as a reminder, recall that when we have these scenarios where the functions are lines, then the tangent lines are themselves. And so if we're trying to find the derivative at any given point, what we need to do pretty much is find the slope of the tangent line. So as an example, in here, we need to find out what is the y dt for t equals 1. Notice that y is equals f of x and x is equals g of t. So what we're really going for is we have a function y equals f of x, right? But x is g of t, so it's f of g of t. So if we apply the chain rule, this will be f prime compose g of t, the inner function, times the derivative of g prime of t. Now, doing that here means that we're doing f prime of g of 1 times g prime of 1. So it is important that we find every single one of these points. First, g of 1. G of 1 is easy to find. Notice that we gotta go to the function g, and then from 1 we find the image. So the image is 2. So g of 1 is gonna be 2, and we're gonna get a multiplication here, f prime of 2 times g prime of 1. Now let's find each of those derivatives. Let's start first with f prime of 2. First, we gotta see where 2 lives. So 2 is here, and the image is at this point, so it's over this line. So it would be good that we find the tangent line here to this point, which is itself. So that means that we can use the slope of this line. But we can find that, the slope of a line, by taking 2 points. So if you remember, the slope in this scenario will be we can do f of 0 minus f of 2 over 0 minus 2. Remember, we're doing the difference sum 2 y's over the difference sum x. So now f of 0 becomes 5 and f of 2 is 3 over 0 minus 2. So this is pretty much 2 over minus 2, and so this is minus 1. So this means that all the slope here is minus 1. Doing a similar behavior, a similar exercise with this line over here, we can find the slope for this one. And you're going to find out that the slope in here is 1/2 for any point that is over this line. Doing the same thing, remember, for example, here with g prime of 1, we checked this point. Oh, okay, so over this line, and we have a bunch of points that we can use. So to find, let's say, g prime of 1, we can again use 0. And so f of 0 minus f of 1 over 0 minus 1. And f of 0 is 0. F of 1 is 2, and over minus 1, so this becomes 2. So the line of this, the slope of this is going to be 2, and doing a similar process, we can find out that the slope of this line is minus 1. So the slopes are fundamental to this exercise. So now that we have that f prime of 2 is minus 1, then we just put minus 1 in there. And then g prime of 1 is 2, because that's the slope that we found out. And so the whole thing is going to be minus 2. Then the rest of this is exactly the same thing. So in here we're doing, well, f prime of g of 5 times g prime of 5. So what is this? Is f prime g of 5 is, I don't know, 2.5. And so thanks to that, 2.5 is over here. So f prime of 2.5 is minus 1. And g prime of 5, notice, is this minus 1 here. Sorry, we have g of 5, not f of 5. So g of 5 is actually 7. And f of 7 is actually 1/2. Okay. All right. So now let's do one more. So this is f prime g of 3 times g prime of 3. So we gotta be careful with getting the right point, because otherwise we can be misled to find to use the wrong slope, like it happened to me here. So g of 3. So who is g of 3? G of 3 is going to be 6. And so this is f prime of 6 times g prime of 3. So f prime of 6 is 1/2, and then g prime of 3 is 2. So this is 1 at the end. Okay. So the important in this question is know how to actually get the derivative from the lines by calculating the slopes and then playing in the formula of the chain rule. Now, question number 4 is a question about units. Here we have the cost of maintaining a water reservoir in dollars, where W is the depth of the water in feet. The depth of the water is changing with the rainfall, which is given by WR, where R is the monthly rainfall that is given in inches of rain. So we need to know what are the units of each of these things. And this is going to be especially important when you're making interpretations of rate of change or functions. So for example, for the first one is C of WR, but this, it doesn't matter, there is a composition. The final output of C is dollars. Now, the next one is a rate of change. So is the rate of change of the cost over the depth of water changes with the rainfall, which is given by WR. Okay, so in this case, since the depth is given by foot or feet here, this will be a rate of change, and it's in terms of dollars per foot. This rate of change here is the rate of change of the depth of the water respect to R, which is the monthly rainfall that is given in inches. So in this scenario, this is going to be feet, which is the units of W, over the units of R, which is inches, because we're measuring inches of rain. Now, the last one is a rate of change of a cost over, which is measured in dollars, over R, which is a measure of inches of rain. So as you can probably guess, this is going to be dollars per inch. And so that's pretty much how the stating of these units goes. As I was mentioning before, this is going to be important when you're trying to make interpretations of rate of change. Now let's go for a sentence that makes interpretation of the chain rule. So we have that the amount of water of an oak tree gives or transpire is related to its size. And we suppose that that's given by the function W of G equals 31.54 plus 12.97 log of G. And we're measuring that in gallons per day. So then we have that the girth of the trunk of the tree in feet is given by the function g of t equals 3 plus 2t feet. We want to know what is the ht of the tree in years, and we want to calculate what is the rate of change of w, so the amount of water, depending of the time. And of course writing the sentence interpretation. So first than anything, let's actually calculate some of the rate of change that are relevant to this scenario. So if W of G is that, then W prime of G is just going to be what? The constant here becomes a 0, and the only derivative here is this log. And so I'm going to have 12.97, since that's just multiplying the log, times 1 over G. Okay? And now, if I take the derivative of G, this is just going to give me G prime of T is 2. So, constant function. Now, with this information, I should be able to find out what the W of T is. T equals 1. So this essentially is W prime composed on G of T, or in this case in G of 1, times G prime of 1. Now let's calculate this. So this will be W, and what is G of 1? G of 1 we plug in 1 here, and so that's going to be 3 plus 2, so that will be 5. So it's W of 5 times G prime of 1. And now what is W prime of 5? Notice that I just got a plug in here. And so that will be 12.87 times 1 over 5. And now let's find out what G prime of 1 is. So if G prime in general is 2, so G prime of 1 is just going to be 2 as well. And so at the end, when I multiply all these things together, this is going to be around 5.188. And let's remember that this is a rate of change, and so what this is measuring is the units of W over the units of T. So this is rate of change is 5.188 gallons day per year. Notice that W changes in gallons per day, and the time T is changing in years. So that's why we have this relationship. So now what will be the interpretation of this? Well, we had that when the tree is 1 year old, right, which means T equals 1, the amount of water or whatever vapor transpire is increasing, because notice that the result was positive. So since this is positive, it's increasing by, and so that will be 5.188 gallons per day per year. Okay? And so that will be the interpretation here. So notice that the rate of change, the interpretation of the rate of change for the most part is still going to be in terms of who is the final rate that we're working with. So in here, it was W in terms of T. So we get the units of W ratio the units of T. Now let's move on to question 6. And here we're trying to arrange what the formula of the chain rule is. So we have f of x equals 5x cubed, and we have x of t equals 3 plus 3t to the 7. Now, if we do composition here, notice that we're plugging x into f of x. So this will be 5xt cubed, since this is what f of x is. Oh, but now we can actually say, well, but what is x? X is 3 plus 3 t to the 7, and then power to the 3. Then remember that now we gotta apply the formula for the chain rule, and the formula for the chain rule is f prime composed in xt times x prime of t. Okay, so we can if we want to, we can find the derivative of each of these parts individually. This is something that you can do when you're doing chain rule. If you have the value of f and the value of x here, you can just go ahead and do it. So f prime of x is just going to be 15x squared okay, I lost what I was doing. Okay, let me go over this again really quick. Okay, so this will be 5 x to the t cubed, and this will be then 3 plus 3 t to the 7 cube. And then we were talking about using the formula of f prime of xt times x prime of t. And so we find what each of this derivative is. This is 15x squared, and x prime is going to be here 21 t to the 6. Okay, so if we plug in this formula, notice that f prime is 15x squared, so this will be 15xt squared times x prime, right? So that will be what? So that will be 15 3 plus 3 t to the 7 squared times 21 t to the 6. So this is one way of doing the chain rule. You identify who are the functions in the composition, take the derivative of each of them individually, and then compose and use with the formula. Now let's take a look to another example. Here we have separated the functions again. We have f of w equals w squared, and w of x is 3 plus the square root of x. So if we do composition, notice that this is really w of x squared, because that's what f of w is. But now we can replace for what w of x is, which is 3 plus the square root of x squared. Again, we can do the same thing. What is f prime? It's going to be 2w. And what is going to be w prime? W prime is going to be, this is a square root. So if you remember, the derivative of the square root is 1 over 2 the square root of x. So now applying the formula for the chain rule here, that will be f prime of wx times w of x, w prime of x. And putting this into the context of the function, this will be do w of x times w prime of x, and that will be twice 3 plus the square root of x times w prime of x, which is 1 over 2 the square root of x. And so that pretty much will be the solution in here. It's worth mentioning again, how did you get the derivative of square root of x? Notice that you have that w of x is the square root of x. That can be seen as x to the 1/2. And so w prime is just 1/2 x to the minus 1/2 once that you subtract 1 from this. And so this is 1/2 times 1 over x to the 1/2. And this is 1 over 2, 1 over square root of x again. And so this is 1 over 2 square root of x. Right? So that's the origin of that particular formula. Now let's do the same for this function here. We have g of y is sine of y, and y of x is equals to log of x. So at this point you probably understand how this works. So the composition g of y of x is going to be sine of 2 plus log of x. And so if you practice enough and you're able to understand that what you really are doing is the derivative of, when you're doing the derivative of this, g prime of y of x times y prime of x, you can kind of jump directly to do what you need to do next. What is the derivative of g? Is cosine. So that will be cosine compose on y of x, which is 2 plus log of x. And then you directly multiply by y prime of x. But what is y prime of x? The derivative of this, which is just going to be 1 over x. And so depending of your mileage, you can go ahead more quickly and get to the result of the exercise. Now let me move to another application. So we have here that the profit generated by the sale of computer chips is given by the function P of C equals 22.35 C power to the 0.9 minus $8,000. The number of chips here produced depends on how long the factory has been in operation. So notice there's a factor of time here. After 50 hours, 1,200 chips had been produced, and the factory is producing 4 chips per hour. Okay, so notice important things depend on how long, right, it's been in operations. So this tells you time. This tells you after 50 hours, so that's a particular time. And we have 1,200 chips, and we have that is the factory is producing 4 chips per hour. So all this is information about the function and the rate of change. Now they're asking me at what rate is the profit, which is the function P, changing when the factory is being operating by 50 hours. So they're asking me for what is the derivative of the profit with respect to time when the time is equals 50. Okay, but because we have a chain rule here in bold, notice that the profit is in terms of how many computer chips do I have, but also the computer chips that I have depends on the number of hours that have passed. So pretty much we have a function P that depends on the cost, that depends on the time. So we have a situation where we have a function P compose cost of time. And so if we want to do the derivative of the profit with respect to t, this is really p prime of cos on 50 times the rate of change of 50. Okay. Now we don't really know how the cos on general behaves. We don't know the information of C of t in general, but we do know the cos at 50, or sorry, the amount of chips that we have at 50 hours, which is the 1200. And we also have information on what is the rate of change for the number of chips being produced per hour. That's the function C prime of 50, which is pretty much 4 chips per hour. Okay, so notice that we have most of the information that we want. So we have now p prime in 1200, and then times C of 50, which is 4. And at this point, then what we need to find out is what is the derivative of p, which we get from this function. Okay. And so at that point, that function p prime of c is what? The derivative of this, which is just going to be 0.9 times 22.35, and then c power to 0.9 minus 1. So that will be minus 0.1. Okay. And so if we multiply this, we're going to get that this is 20.115, and c to the minus 0.1, and we can plug and see how much this is going to be when it's 1200. So this will be 1200 to the minus 0.1, and that's going to give me and times 4. I forgot the times 4 here. And so that is going to give me around 39.60. But remember that this is the derivative of p with respect to time. So this is going to be units of dollars, which is the profit, per unit of hours. Okay. And of course, then you can make an interpretation here of how much this is having. When you have when you have 50 after 50 hours, then the profit generated is going to be $39.60 per hour, or is increasing at $39.60 per hour. Okay, for the next question, we have a chain rule that is really simple. We have f of t equals t to the 6. And t of x is given by this function. So we want to calculate the chain rule. So there are two ways of doing this. First, you can establish what is f of t of x, the composition. And this is just really 5x squared minus 7x to the 6. So if I don't want to split this and make multiple derivatives, I can just do f prime of compose tx times t prime of x. So what if f prime? F prime is 6 t to the 5. But then because we're composing in t of x, it will be 6 t of x to the 5 times t prime of x. And then that will be 6, and then now we can compose with what it is. 5x squared minus 7x to the 5 times, and then do the derivative of t of x, which is going to be 10x minus 7. Right? And so that will be the chain rule in there. Now to finish up this first video, let's go with one question in terms of the average rate of change. So in 1999, we have that the number of physics research articles published by the US researchers was 4,300 articles, and it was increasing at a rate of change of 200 articles per year. We want to know what is the percent rate of change of the number of physics research articles published by the US researchers in 1999. Okay, so it's the percent rate of change. So if it's the percent rate of change, remember the percent is the part over the whole. So a percent is equals part over the whole. And so the percent rate of change really is the rate of change over the function. So if let's say here the function is given by f, I have f prime, and I want to know what is happening in 1999. So it's f prime of 1999 over f of 1999. Okay, but I have the information on that. This is happening in 200 articles per year in terms of the rate. It's increasing at the rate of 200 articles per year. And I know that year 4,300 articles were produced. Okay, so if I divide this here, this is going to be 0.0465, and so this will be the percentage per year of the number of physics research articles published in the US. All right, see you in part 2.